Hey there guys, I thought I'd do a little video with both of the methods I have showed you for changing fractions to percentages, and then in this video then you can compare the two different kinds and get really good at both of them, hopefully. So I've done up this little table which is like a step-by-step instruction for both methods, okay? And in the top here I've highlighted which one I'm talking about at different points. So the first one is fractions to percentages using our knowledge of equivalent fractions. This one I find has a few less steps, and some people find this one a little bit easier. So when you come across these, that's a real bonus. The second one I'll talk about in a minute when I get to that step. Okay, so I'm going to do a worked example now for you of this first method. So 3 steps here, and this is for when it's easy to multiply a denominator and change it to 100. So we're talking about when you get a fraction, let's say it's 3 over 25, and you look at that fraction and you know that the denominator here, 25 in this case, is pretty easy to turn it to 100 by multiplying. Okay? So you're thinking to yourself, what can I multiply this denominator by to change it to 100? And in this case it's 4, because 4 times 25 is 100. So your first step is to ask yourself that question so that you know it's the right kind of fraction for this technique. And then you're going to write in your working 100 over here. Now I do want to see you do this working so it's very clear to me. And then in the off chance you make a mistake in an exam, if you do have the correct working, I can still give you some marks. Okay, I say that often. Okay, so we're going to go times 4. And then our rule with fractions, and what we're doing here is finding an equivalent fraction, 25 to 100, is whatever we do to one part of the fraction we must do to the other. Exactly the same, okay? Otherwise we're actually changing the size of the fraction, and that's not really what we're after today. So, because I've times this by 4, I'm going to times the top by 4 as well. So 3 times 4 is 12. And we know that whenever we have a fraction that is written over 100, that is exactly the same as our percentage, because percent or percentum means out of 100. So the last thing I need to do is just write my percent as a percent instead of a fraction over 100, and you're all done. Okay, presto, this is your percentage. Okay, so let's say I have a fraction that I look at the denominator and it's really challenging to see how I can change that denominator to 100 by multiplying. Okay, so that's when you see that you need to use this method here, this second method. It says fractions to percentages by timesing by 100, for when it is not easy to multiply a denominator and change it to 100 like we did just before. Okay, so there's actually 5 steps here. I know it says 6, but 5 that you need to do your working for. Okay, so 4 over 15 is my fraction. It's challenging to see how I would make that into something over 100. Oops, I didn't try equals yet. So my first step is to times it by 100. That's the technique we're using today for this kind of fraction. But we know that whenever we have a whole number, that's sort of the same thing as writing the whole number over 1 as a fraction. We don't go around doing that with all of our whole numbers. It would take too much time. So we often leave it off. But if I add it over 1, that means later, when I go to multiply my fractions, it's really easy because I just multiply my top, my numerator, and my denominator. Okay, so now I have 2 fractions I can multiply. But if we can, we always try, we've done those 2, we always try to cancel. Okay, so just a reminder, when you're cancelling, I've just written it in brackets there. Okay, which is the biggest number that divides into a numerator and a denominator? So when we're cancelling, we're looking for a pairing. It can be within the same fraction, or it can be one numerator and one denominator, in which case, in this question, it's from 2 different fractions, and that's totally fine. So you're looking for the HCF, highest common factor, the largest number that's going to go into your 2 numbers that you're going to cancel. And the purpose for cancelling is to make them easier to work with. In cancelling, you're making them smaller, okay, by dividing. Alright, so my trick when we're looking for HCF of 2 different numbers is to choose the smallest number, in this case 15. Think of the factors, so we've got 1, 15, 3 and 5. And see which of those factors also work for the number 100, okay? So 5 is going to be our HCF today for this number. And if you choose the smallest number to write those factors down, you end up saving yourself a little bit of time, okay? That's why I say choose the smallest number. So we're going to divide by 5, just these two, and that's going to change my fraction slightly. So 15 divided by 5 is 3. And I always cross it out so that I don't accidentally write the wrong number down and make a transfer error. 100 divided by 5 is 20. Okay, what I'm going to do now is to rewrite my fractions so they're really clear. 4 over 3 this time. Now this is 20 over 1. Please make sure, guys, that you do show your working at every stage, because it just makes it really nice and logical. Don't be afraid of overusing your pencil, I always say. Okay, now that I've got a smaller fraction to work with in terms of the numbers, I'm going to times across my numerators, so 4 times 20 is 80, and then across my denominators as well. 3 times 1 is 3. Wonderful. Okay, so I've cancelled, awesome. I've multiplied my numerators and then my denominators, and now I need to simplify. So when we're simplifying, we're looking at making the numbers smaller, but actually the size of the fraction is exactly the same. So if it's a proper fraction, small on the top, bigger on the bottom, you're going to just make those numbers smaller by dividing. But if this is an improper fraction, so heavier on the top as it is on the bottom than it is on the bottom, we're going to do our changing to a mixed number. So I say, how many times does my 3 fit into my 80 in this case? And that ends up being 26 times. 26 times 3 gets me to 78. So I actually have 2 remainders, and I write it over my denominator of 3. Okay, if you get to a question like this, and you can't, you're frazzled or you're not really great at your multiplication, and you can't think how many times 80 goes into 3, just go over here, okay, and do a division. Okay, so 3 goes into 8. How many times it goes in twice? It gets me to 6. I have 2 remainder, and so I have 3 into 20. That goes 6 times, and I have remainder 2. And that is exactly what I have here, 26, and my remainder 2. Okay? And then I just write it over my original denominator of 3. Now, I would really love if you could then change it to a decimal. Now, I know we haven't done decimals yet, but lots of you will know that 2/3 is the same as 0.6 repeated. So I'm going to say 26.6 repeated percent. Now, as we get into our decimals, you guys will get to know how to convert those common fractions to decimals really well. Okay? If I was being really pedantic, I would say that it's 26.7 rounded up percentage. If I was being extra pedantic, I would say 27% to the nearest percentage. Whole percent. Anyway, this is fine. These two. Alright. Good luck, guys. Let me know if you have any questions.